Hey Calculus, this is from our textbook, section 7.4, Exponential Growth and Decay. Note we skipped 7.3 because it's not in the AB course description, but if you want to read it, you can. It's a different method for integrating. You're supposed to do this on your own. It's been a while since you've done some of these. You could pause and check your work there. And I also wanted you to do example 1 on your own. Mine's a little messy, but there's the answer. I wanted you to check it on your own. Maybe we'll go over it if I have time. We're going to go to the back. Here we go. You may or may not already know that for exponential growth problems, the rate of change is proportional to the amount present. What that means is the more bacteria in the dish or money in the account, the faster the amount will multiply. So the more money you have, the more money you're going to make, the more bacteria in the dish, the more it's going to grow. Now, if something's decaying or going down, like the more radioactive material present, the faster it decays. So, thus the differential equation is proportional to the amount that was in there. So dy over dt is equal to k times y. K is the constant of growth if positive, or decay if negative. Solve this differential equation for y. So we're going to start with dy over dt. Now we have dt instead of x because it's with respect to time. And the first step is to separate the variables. So we're going to do that by moving the dt to the right-hand side. And then we're going to divide by y over here. So starts off kind of messy, but this is what it looks like. 1 over y dy equals k dt. So after we separate the variables, we're going to integrate both sides. Now when we integrate, I'm going to rewrite it. Some people separate the variables and integrate like all in one step, and it is too confusing to read and very confusing to grade for the person grading it. Okay, so there's my integral. Now the integral of 1 over y, because it's y to the 1, this will be the ln of the absolute value of y equals k is a constant and our variable is t. So the antiderivative of a constant with respect to t will be kt. See, what's the integral of 2 dx would equal 2x, like that. And what do we need to put here? Plus c. You thought you were doing math, but this is really kindergarten. I mean, there are 0 numbers here. Do you see that? ln y, vertical lines kt plus c. Kind of funny, right? Okay, what do we need to do? We have to solve for y. So, to cancel this ln, we're going to take the e of both sides. E. And we get to drop the absolute value because anything, e to the power of anything will always be positive. So that's why that absolute value is there, and then it drops on the next step. Okay, I would love to be done right here, but calculus, they like to keep going. And do you see how the exponents are being added? If you add the exponents, and that means the bases are being multiplied. So this is e to the kt times e to the c. You still with me? Then they like to do this. It's silly, you guys. They like to say, they give it a new letter in front. A, e to the kt, with a being the plus or minus constant e to the c. I know, it's silly, okay? Now, this a in front, now all of a sudden becomes a why not, because why not? That's lame. It's been a long week, you guys. Okay, stay with me. Do you see this? What if time was equal to 0? Okay, let's plug in 0 for time. Do you agree we have e to the 0? what's anything to the power of 0? This is a 0, 1. So the number in front, you ready? The number in front is always your starting amount, your initial amount. So how much money was in the account? How much bacteria was in the petri dish? How many people? A lot of these are population questions. How many people were in the population at the beginning? Okay. What does this all mean? If y changes at a rate proportional to the amount present, so if you know this, the goal, my friends, if you know this, is to not do all of this work every single time. So if you see the word rate proportional to the amount, then you know this, and then we know this. It's already done. It's solved for y for us. Okay, that's the goal. It's like a shortcut. And we're going to practice this. We're going to do some examples here. You have a real quick homework here, and then we'll practice some more in class with a little activity. Okay. Find the solution to the differential equation. Do you see how this is given? So this matches this, which means we know this. That's all. That's it. That's it. Yep, that's it. So because it matches proportionally, or the rate is proportional to the amount, just like that, that matches there. K is a constant, satisfies the given condition. So this is number 12 from the book. Ready? Get set. So we know dy over dt equals ky, which automatically means, you ready? You get to write y equals y naught. Y naught, that means the initial amount. It's a little o, it's not a 0, it's a little o, e to the kt. Okay, now this was the given information. You ready? Don't think too hard. What is the starting amount? So what was y naught? Y naught is equal to, do you see how it says y of 0? So y of 0 is 200. So they gave us the starting amount, e to the k. What's k? They gave us that. Okay, that's it. That's number 12. We're done. Find the solution to the differential equation with k as a constant that satisfies the given conditions. Okay. Now on this one, did they give us k? No, here we just plugged in k. They didn't give us k, so we're going to find it. And we know that y equals y naught e to the kt. So y naught, do they give us the initial condition? Did they give us the initial condition there? 60. So we know 60 goes here. And then they gave us a second point. So after 10 years, the population, so at the beginning the population was 60, and after 10 years the population's at 30. So we're going to plug in 10 and 30. So 30 is y, 10 is our t value, time, and solve for k. So the population got cut in half. We see that. Half equals e to the 10k. What do we do next? How do we get rid of the e? So we're going to take the ln of both sides. So the natural log of 1/2 is equal to 10k. So k equals the natural log of 1/2 all divided by 10. Divided by 10. Like that. No, we're not done yet. The goal wasn't to find k. We were supposed to solve for y. So here our answer is y equals 60 e to the k. So our k is this wonderful thing here. So let's see. Over 10. And then t is like that. Okay. That's correct, but we can simplify it. And this is going to require some logarithm rules. And I'm sorry, maybe I could have done it down here. Do you agree that this is 1/10 times the ln of 1/2? Yes, which means we can move this 1/10 up here. So this is really ln of 1/2 to the 1/10 power. I know that's a weird power, but that's okay. We can do it. Okay, if we rewrote it like that here, then do you see the E would be touching the ln? So it's like we had to move that 10. So we moved it up here. The E is touching the ln, which means we're going to have 60. Should I write it out and cross it off? Ln of 1/2 to the 1/10. And then we have this T hanging out here. It's kind of funny. Ln is touching, so you go hiya, karate chop. Okay, what does that do? That brings the 1/2 down. 1/2 is now our base to the power of 1/10 times T. The T is still up there with the 1/10. That's it. That's kind of a funny one, right? Okay, so what are you going to do? You're going to practice 1 through 9 odd are solving diffie-qs. Yay, more practice. And then 11 and 13, 13 are like this. And we're going to do more growth and decay examples in class, in activity. Okay, did you do the one on the front? I wanted to show you I hope this is right. I hope I didn't make any mistakes. Maybe I should check it before this video ends. Okay. Ta-da. All right, I just checked it in my head and it looks good to me, but if anyone can see a mistake, let me know. Appreciate it. And do your homework. Hope you all have a good weekend.